Hey everyone, you know, while everyone is talking about AI these days, ChatGPT, Gemini, Cloud, those are amazing tools that can write an essay, that can write a code, even sometimes having a conversation. And honestly, it feels intelligent, right? Like there is some super brain on there. But the surprising thing is AI, so especially this language models, isn't actually intelligent as how we think intelligence is. And today we are going to break down what is going on under the hood. So to get to the big stuff, let's start with the basic. What even is a language model? Well, basically a language model is just a computer program designed to understand or generate a human language. Think of it like this. Its main job is to predict the next word in the sequence. That is. It is super simple, right? It is all about patterns and probabilities. Let's do a quick but simple example. If I say the cat sits on blank or dash, what is the most likely next word? Mat, right? Or maybe calf or maybe floor. A language model learns these probabilities by looking at ton of text. It sees a cat on the mat many times, so it learns that mat is pretty good guess. Now there are a couple of main ways this models learn. You have got what we call autoregressive models. Those are like our example. They predict the next word one after the other based on everything they have seen before it. Think of it like always look forward. Then there are masked language models. Those are a bit different. Imagine you have a sentence and you had a word in the middle, like my favorite blank is blue. Is masked model tries to guess what hidden words by looking at both the words before and after. So my favorite blank or dash 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 is blue. Most probably you can understand my favorite, then it is the first means the word before, and is blue is the word after. That means there is something missed between the favorite and the blue. So the LLM or language models can guess what words need to be filled in between my favorite and blue. That is color, as you know, most probably. And okay, it gets a float context. Both are super models, but for generating text, autoregressive is the key. Okay, so we know what language model is. Now, what is an LLM? A large language model. Honestly, it is exactly what it sounds like. Really, really big language model. We are talking about a model with an insane amount of data and mind-blowing numbers of internal connections, or what we call parameters. That is the large part, actually. So why did they get so big? Well, it is a bit of a perfect storm, actually. First, data. We suddenly had access to massive amount of text data, the entire internet, basically books, articles, conversations, codes, everything. Second, parameters. These models have a billion, sometimes trillion of internal knob and deals that they adjust during training. More parameter means more complexity, more neurons they can capture, and third is compute. We got a powerful enough computers, especially GPUs, to actually train this colossal models on all that data. Without all three, LLM wouldn't be where they are today. Now, before we talk about how they generate text, we need to now about some crucial concept. It is token. See, computers don't understand the word like car or intelligence. They understand numbers. So when you give a text to the LLM, it first goes through something called tokenization. This tokenization breaks down your text into a smaller units called token. And a token can be a whole word or a part of word or punctuation mark or even just a space. Example, the word unbelievable might be broken into unbelievable. Each token gets a unique number, and that is what the model actually processes. So with our text turned into numbers or tokens, what is the core idea? It is all comes back to what we said earlier. Next token prediction. The model looks at the sequence of tokens it has so far, and then it calculates the probability of every single possible token in its vocabulary. It is like it has a giant list of all possible tokens, and it assigns a percentage chance to each one, being the next best fit. Let's go back to our cat example. If the model has processed the cat set on the blank, it is not just guessing Matt. It is actually saying, okay, Matt has 60% of a chance, Coach has a 20% of a chance, Floor has a 10% of a chance, and Dog has a 0.001% of a chance, and so on for 1,000 probabilities. Then it picks one, usually the most highest probabilities. Or sometimes it picks the slightly less probable one to make it sound more creative or less repetitive. And now here is the interesting part. How does we get a full sentence or even a paragraph from just predicting one token at a time? Well, it is a loop. The model predicts the first token, then it adds the token to the original input, and then it predicts the next token based on the new or longer sequence. It just keeps doing that, one token at a time, building out the response until it decides it's finished or it hits a certain length. It is like building a Lego tower, one brick at a time. Each new brick is chosen based on all the bricks already laid. So why does this process, which is essentially just really good pattern matching, feels so intelligent? Honestly, it is because those models have seen so much human language. They absorbed patterns, styles, facts, and even nuance from the billions of words. When you ask it a question, it is not understanding your question as a human sense. It is predicting the most statistically probable sequence of words look like an answer to your equation based on all the answers it sees in its training data. It's mimicking intelligence and incredibly well. let's quickly visualizing this whole thing. The user type an input or a prompt that gets broken into token. Those tokens go into the model, which is a giant complete network of probabilities. Then the model predicts the next most likely token, and the next and the next, until it forms the complete output. The response you see on your screen. Simple is that really. So the big takeaway, the reality check is this. These amazing LLMs or large language models are powerful prediction machines. They are incredibly good at generating command-like text because they are learned the statistical relationship between words and ideas from vast numbers of data. But they don't think, they don't have a consciousness. They don't understand in the way a command does. And they predict and understanding the distinction and the thing. I think this is a super important as we navigate this exciting new AI world. All right, I hope that helped demystify things a little bit. If you found this video helpful, please hit that like button and subscribe for the next video, as we are going to create release a series in LLM and RAG and agents and more in the next. Thank you for watching and see you in the next.